Nickel is a versatile metal that is found in abundance in Earth, crust, and core. Nickel exhibits several desirable properties that render it useful in industrial applications. For one, nickel is highly ductile and valuable as an alloying element to alter the properties of other metals. For example, grades of stainless steel can be created by the addition of nickel to produce alloys that offer corrosion resistance and high temperature endurance, making them ideal for the uses in chemical plants where exposure to chaotic substances may be expected. Nickel, whose chemical symbol is Ni, has a silvery white appearance and is a primordial element with a face-centered cubic crystalline structure. It is magnetic at room temperature and has a Curie temperature of 253 degrees Celsius. Nickel will alloy easily with most metals such as copper, chromium, iron, and molybdenum. The addition of nickel to other metals alter the properties of the resulting alloy and can be used to produce desired characteristics such as improved corrosion or oxidation resistance, increased high temperature performances, or lower coefficient of thermal expansions.
Methodology of fabrication process of the nickel alloy as a tubing blade in Air Force application is forming and casting operation. For forming fabrication, the technique used is forging. Forging is mechanically working or deforming a single piece of a normally hot metal. Forging is divided into two, namely closed die and open die. In the process of manufacturing this blade tubing, we use forging closed die. That is, a force is brought to bear on two or more die halves having the finished shape such that the metal is deformed in the cavity between them. Producing blades with forging method is hard for the sake of high equation of forging surface to volume. That is why the important element of technological process planning is adequate tool design and ideal perform shape selection. Also produced through investment casting process using nickel-based superalloy. For investment casting, sometimes called lost wax, the pattern is made from a wax or plastic that has a low melting temperature. In the process of casting, investment is divided into two stages. Stage 1 requires mathematical simulation of casting solidification, drawing documentation of mold, wax model, casting cluster, production of ceramic shell mold, and finally casting. For stage 2, needs welding, machining, coating, moment balancing, and finally hardware installation. The operation temperature range of these components is very close to the melting point of this alloy. Investment casting process with complicated aerofoil shapes and very thin wall thicknesses to with compressed clean air is prevalent.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zaim Taqiuddin bin Muhammad Yusof. My metric number is RS21081. The conclusion as the turbine blades in aerospace application is, in case of engine, the turbine used in the turbochargers. The turbochargers engines are popular for getting efficient fuel burning and other advantage. The gas turbine powered engines are popular like jet engines. Mostly, they are favorable in the power generation sector. There are different parts associated with the gas turbine. We will check them on one by one. Turbine blades cast using an iron-based superalloy who withstand extreme temperature and pressure. The ceramic cores will help this blade to generate hollow cavity of turbine.